Interest rates play a crucial role in financial markets, impacting everything from bond pricing to loan valuations. Since future interest rates are uncertain, financial professionals use stochastic processes to model their movements and assess risk in fixed income investments. Why simulate interest rates? Interest rate simulation helps in bond pricing, estimating future bond prices and yields. Risk management, assessing exposure to rate fluctuations. Derivative pricing, valuing options, swaps, and structured products. Economic forecasting, predicting central bank policy effects. Types of interest rate models. Several stochastic models are used to simulate interest rate movements. Each model offers different assumptions about randomness, mean reversion, and volatility. 1. The Vasicek model assumes interest rates follow a mean reverting process. Models rates as drifting toward a long-term average with some randomness. Limitation can lead to negative interest rates in some cases. 2. The Cox-Ingersoll-Ross CIR model, also mean reverting, but ensures rates remain non-negative. Used for bond pricing and risk management. 3. The Hull-White model extends the Vasicek model by allowing time-dependent volatility. More flexible and widely used in derivative pricing. 4. The Black-Derman-Toy model, a binomial tree model for interest rates. Useful for pricing bond options and mortgage-backed securities. Monte Carlo Simulation for interest rate modeling. Monte Carlo simulation is often used to generate thousands of potential future interest rate paths based on these models. Steps in Monte Carlo interest rate simulation. 1. Choose a stochastic model. Select Vasicek CIR or another model. 2. Estimate parameters. Use historical data to determine drift, volatility, and mean reversion rates. 3. Generate random interest rate paths. Simulate thousands of possible future rate movements. 4. Analyze outcomes. Compute expected bond prices, duration, and risk metrics. Example: simulating interest rates with Monte Carlo. Suppose we want to forecast 10-year bond yields using the Hull-White model. We generate 10,000 simulated rate paths over 5 years. Each path represents a different possible future of interest rates. We analyze the average rate path and compute confidence intervals. This helps in pricing bonds and managing risk. Applications of interest rate simulation. Fixed income portfolio management, evaluating risk and return. Central bank policy analysis, predicting monetary policy effects. Stress testing, assessing financial stability under different scenarios. Mortgage and loan pricing, forecasting future borrowing costs. Challenges in interest rate simulation. Model risk. Choosing the right stochastic model is critical. Computational complexity. Thousands of simulations require high computing power. Sensitivity to inputs. Small changes in volatility or drift affect predictions. Conclusion: Monte Carlo simulation provides a robust framework for interest rate forecasting, helping investors and financial institutions make informed decisions. By simulating thousands of rate paths, financial professionals can better understand bond pricing, risk exposure, and policy impacts. As financial markets evolve, advanced stochastic models and computational techniques continue to enhance interest rate modeling and fixed income analysis.